Hello, everyone. I'm Tomasz Tarczyński. I work at Gigaset as a system architect. And I want to talk today about configuration management in the cloud-native world. So I will introduce a pattern called GitOps. Already today, we had another great talk on operators by Adam Sandor, and he briefly introduced this pattern of GitOps. But let me just ask you, how many of you heard about GitOps already? Okay, and keep your hands up if you use this in practice. Okay, that's great. So I hope what I would talk today would be informative for you. So the plan for today. I'm gonna first give a very brief introduction of configuration management as a concept, then talk a little bit about why we need something like GitOps, something special for cloud-native type of environments. And then I will try to show you a demo of some tools that can be used for this. Okay, so to start with, what is configuration management? For me, configuration management is mainly about defining all of my infrastructure as a code, and then storing this code in version control. So, work way, I can have Git as a single source of truth about my whole environment. So then, basically, our team working with some complex application can use the very same processes that developers use to managing infrastructure. So we can have things like pull requests, peer review of all the changes, stuff like this. And some of the tools typically used in that space are things like Puppet, Chef, or Ansible. So let me ask you again about those tools. How many of you have used some of those? Okay, so most probably you are already very familiar with the workflow. Personally, the tool that I've used the most is Puppet. And here are just few of the most important characteristics of. So what I really like about such way of managing infrastructure is first, it provides me with a very simple domain-specific language. So it's constrained, but it's much easier to use such kind of language than, for example, learning and coding all infrastructure in, let's say, Python. Then it's declarative. So it means we only describe the desired state of the infrastructure, and then we have a fully automated way, so a tool that would automatically apply this whole desired state configuration of my system to the system itself. It lets me do templating of all my configs. So there is a templating engine and the special templating language. And then another something important for me, it's modules. So I have a way to sharing code. If, for example, I implement some automation for some complex application, I can share it with other teams, and I can also use some publicly available modules. For example, let's say I need to automate a database deployment. So I can get just public module and use it for that. Okay, so that was it about configuration management as a thing. And now let's move forward to what we have in our infrastructure today. So we start using orchestrators like Kubernetes, and they promise us some great things. So there is a control plane in Kubernetes, and this control plane provides us already a declarative API, similar to what I had in Puppet, maybe. So I can, again, just declare the desired state, and then it means I just write a lot of YAML files, and then I need only to put those YAMLs to the cluster. And there is an automation in this control plane that constantly makes sure that my actual state of the cluster will always match this, what I've defined as my desired state. So having a system like that, do I still need something more for managing my configuration? And I would say yes, I really need something more. But the scope would be smaller than in Puppet, but I would like, again, a fully automated way for taking my configs from version control, from Git, and automatically applying them to my cluster, to my environment. And I would also have some automated agent that would constantly verify if the state that is stored inside the cluster, does it actually really match what I have in version control. Another nice thing to have would be some method for sharing my code, my configuration, internally within my organization and also with others publicly. And Kubernetes itself doesn't cover those two, so we need some special tools for that. Again, about configuration management, there are two approaches, let's say. We can either manage our configuration imperatively. That would mean I have a list of commands or a simple script that would apply changes one after another to my environment. And this is called the imperative way. And the other approach is declarative. So I only describe the desired state. How should the environment look at the end? And I don't really care about what steps are made to go to that state. Okay, and now taking a look into how we usually configure things in Kubernetes. So a very, very simple view here, but we've got an operator here. It could be a person or maybe your Jenkins instance or some script, whatever you have. But to deploy something in Kubernetes, you usually mainly have to do those two steps. So you build your Docker image, push it to the container registry, and then once your image is built, you need to invoke some commands to the Kubernetes API. So you run things like kubectl apply, and you are just pushing your configs to Kubernetes master server to the API. And then you hope that on the master server, it will just run your deployments, run your application, and pull the images from the registry. But this approach, I would say it's still quite imperative. So you have this list of kubectl apply commands, and you that way apply your state. And what can we do to improve this? There are a few different possibilities, but one of those is a tool called FluxCD. It's basically a GitOps operator. So a quite simple agent that runs inside your Kubernetes cluster, and it has quite simple role. So it constantly reads, synchronizes with your Git repository, and then it applies the whole state described in Git to your cluster. And just recently this year, the Flux project, it joined CNCF, so Cloud Native Computing Foundation. So it's also nice that it's developed in the open, and now more and more integrations with different cloud native tools are developed. So we had this view of how our imperative approach would work. And now what would change when we introduce Flux as a GitOps operator? So we add this autonomous agent to inside our Kubernetes cluster. As an operator, I no longer do any commands like kubectl apply, so any commands that would modify the state in Kubernetes, but rather than that, I would rather put all my YAMLs inside a Git repository, and then I want my Flux operator to read these commands from there and to apply all the changes to Kubernetes API. So as I said, quite simple concept, but I would say it changes quite a lot. Okay, so now it's a demo time. I will try to show you how it works in practice. All those demos are available in GitHub, so if you want to try it yourself, you can just clone the repo and try yourself doing the same. Okay, so what I have here in this Git repository. Is the font big enough in the last rows? Okay, okay. So I have a very simple application to be run in Kubernetes. It's just as simple as we first define a namespace, then we've got a very small configuration with just a simple HTML file to be displayed from the web server. And then we're gonna create Kubernetes deployment and a Kubernetes service. So let's see the deployment. It has some labels defined. Especially interesting for us would be that it is the blue instance of my application, and this is version 1.10. And if we look what's deployed here, so it's Nginx web server, just in this particular version. And then my service, it's also something very simple. It's basically exposing exactly this application, and it is exposing the blue instance in that case. Okay, so having this simple app, I will now use Flux to just deploy it to my local cluster in Minikube running here. If you would like to try this yourself, you've got those steps to install the tools. So you would need to install Helm and Flux, but to make this presentation brief, you would just skip to the demo. Okay, so we'll start with taking a look how this Flux is actually installed and how it's configured in my cluster. So I've got a Flux deployment, and then if I look in detail into this, I can see that it's just yet another simple Kubernetes deployment with this Flux application running inside. And the only parameters that would be interesting for me right now are those. So I have configured this agent to synchronize with my repository in GitHub, to look for the branch master in this repository, and then the directory manifests is where the operator would look for all the YAML manifests. One more thing that could be interesting, poll interval. So it's actually synchronizing every 15 seconds. So we will see some effects of this. Okay. So let's try this out. First, let's see my manifest directory. So currently it's just an empty dir, and we will add YAML files there and see how Flux works. So we will observe what's going on inside the cluster. So there are currently no objects in namespace demo. And then I'm gonna to copy this application definition to the manifest directory. And the next step is just committing this change to Git. And then I will push it to GitHub and observe how the changes got applied to the cluster. Okay, so the changes got pushed. And now we need to wait something like 10 or 15 seconds for the next synchronization to go on inside the cluster done by Flux. So just in a short moment, we should see that our objects in the cluster got created. So we've got the namespace, service, config map, and deployment created. And here we can see that actually, yes, our deployment is already here, the pods, service, and the config map. So that was just the simplest thing, Flux installing our application in the cluster. And then the next one would be like our workflow of how we work with applications in Kubernetes. So working declaratively with our configuration, how do I apply changes to what's going on in my cluster? So again, I would observe the state in the cluster, and so I've got those two pods with version 1.10. And when I make curl to my service, I got also information about what's running there. And then to apply a simple change, I will just change version from 1.10 to 1.11. So let's apply this. We've got two different YAMLs change here. And now I am again committing the change to Git. And again, we'll push it to GitHub and then observe how the change got applied. So now the change got already pushed to GitHub, and now we just need to wait a short moment, and now it's already applied to the cluster. So we can see that those objects got configured. And here we can also see that the change inside the cluster is already applied by the Kubernetes API. So it's already going on. Okay, and then another example what this approach gives us. So we're still observing the state of our cluster, that there are two pods and that our application responds. And then I'm gonna do something like, let's say by mistake, one of administrators would delete in that particular namespace. So they thought they work in the testing environment, but they, by mistake, let's say, deleted the namespace in production. So I'm gonna delete the namespace and then watch what do we have in logs. So basically, my application got deleted, and now my Helm operator should again compare what's defined in Git with what we have in the cluster, and then when it spotted that those objects were not in the cluster, it created them back. And then again, I have my application up and running. So that means that in that case, even in such scenario that my application was deleted by mistake, I have it up and running within something like maybe 1 minute or so. Okay, so that would be almost it for the Flux demo. One more thing that we need to do, so I want to clean up this environment before the next part of the demo. So again, watching the state in the cluster. And then removing things from the cluster would just mean to remove my YAML files. So I'm removing this from Git, pushing the change to GitHub again. And then when the change is pushed to GitHub, Flux should delete all the resources as they are no longer in the Git repository. So again, we need to wait for maybe 15 seconds or so. Okay, and that way, all those resources got deleted. Okay, are there maybe any questions to that part already, or? Okay, yes? Okay, so we will get to Helm with the next part. So yeah, I will still talk about this. Yes? Yep. Yep. So for me, the biggest change here, it's that I have this single place which I can treat as a single source of truth. So in one place, in Git repository, I have the complete description of my whole environment. I also got the whole history. If I want to know about, yep. Yep. For me, it basically both could be fine, I would say. Is it a push model here from the CI server or the pull model, how it's done here? Pretty much both could be fine, but I would say, still for me, this Git in the between, it's a big difference for me, because I could still configure it like having the CI server here, then apply the changes from the CI server to Git, and then having my my cluster pulling from there. So, yeah, just like that. Okay, so I would now move to the next part. So, as we've already introduced this Flux as a GitOps operator, and we already have all the state declared in Git. Another thing that I would like to see would be something similar to Puppet modules. So some way of sharing code. And yeah, exactly of what you've asked there. So some method of describing more complex applications. For that purpose, Helm is something really, really useful. So it's, I would say, currently a de facto standard in the cloud-native ecosystem for managing or complex deployments. It's described as just as the package manager for Kubernetes. And let's see what it allows us to do. So we can manage the complexity of our applications. So if we've got some dependencies, some multiple configs, and probably some pointers that we would like to tweak, we can do that with Helm. It helps us with managing updates. So it can manage the workflow of upgrading our application. Then it allows us for this simple sharing of configs, this configuration code, let's say, with public and private repositories, and also rollbacks. They become very simple. With Helm, we can have the history of our deployments within the cluster, and then we can roll back the whole thing. So not just rolling back the deployment object in Kubernetes, but actually back the whole description of my application with all the other things like config maps, services, stuff like that. Okay, so now a very short demo of how Helm works. So I will not actually show the typical use of Helm, but only will give you a brief description of how we can manage our configuration with Helm. So I've created a very simple Helm chart describing the same application that I was showing in the previous demo. And what's there in the Helm chart? There are basically all my YAML files, as it was previously in the previous example. But then I've got one more important thing. It is this values file. So I would like to treat those YAMLs as templates. So I would like to apply some modifications to them, and then I would have some default values for the parameters. So let's see how it looks like. So in my values file, I've got parameters like there is the blue instance of my application with the image version being 1.11, and the green one has the image version 1.12. So I would like to do something like blue-green deployment. And then in my YAMLs, I've got an image defined as a template which just gets this value from either from my values file, or I can later on put my some different value there. Okay, and now let's just take a look into how it works. So we will generate the resulting YAML files from those templates. And then if I take a look into the values here, so I've got the blue deployment with 2 replicas and this version, and the green with 1 replica. And then let's take a look into the resulting YAML files. So the Helm templating engine generated YAMLs for me with 2 replicas here and 1 replica here. And also the service YAML was generated with pointing to the blue instance of my deployment. So I would like to later have this possibility to make a very quick and simple switch between the blue and the green deployment. Okay, so that would be in the very, very brief description of what Helm itself does. Actually, in a real use case, it would do some more things for you, but just for now, this would be enough to see how it works. And now just to connect those two things together. So we've got Flux that gets our configs from Git and applies to the cluster. Then we've got Helm for managing complex deployments. And now we want to use both those together. So there is another part of the Flux project. It's called Flux Helm Operator. And it, again, follows the operator pattern. And the function of this is, again, quite simple. It automates the releases of Helm charts. So it lets you automate the process of installing those charts to the cluster. It does it by defining a custom resource within Kubernetes. The name of this resource is Helm release, and the only thing that you would need to do to configure your complex deployment would be actually to put just a single YAML defining such a Helm release, and then the operator would install such release using Helm inside your cluster. And that's a picture how it all would look like running in Kubernetes. So you've got an operator here who puts all YAML definitions into Git. Then this the Flux agent is just the same as in the previous example. It pulls configs from Git, applies those to Kubernetes API, but then the specific kind of the resource in Kubernetes could be the Helm release, so a custom resource. Then you've got the second operator, so Flux Helm Operator, that looks for those objects, and if it finds the Helm release object, it will connect to Tiller. So in case of Helm version 2, it will connect to Tiller and install your deployment within the cluster. So it's just like we've got those 2 steps, 2 different operators running inside our cluster. Okay, so let's try to see how it would look like, how it works. So I've got it already installed, so we'll skip straight to the demo. So inside my cluster, I've got those two operators running. So there is Flux itself and then this Flux Helm operator. And what I'm gonna do is just to install yet another 2 YAMLs into my manifest directory. Okay, and now just let's take a look what's there. I've got a namespace definition as a first YAML, and then the second one, it's my Helm release object. So then, as I've put all of those YAMLs defining my application into a Helm chart, then to install this application, I need only such a simple YAML file, simple object. So this is a Helm release. It runs, it goes into namespace demo, and it uses the chart from my Git repository in GitHub, from branch master, and the path to the chart is charts demo. Okay, so I will now watch the state in the cluster. And then I'm committing those changes to Git. Then we'll push those and again observe what's happening in the cluster. Changes got to GitHub, and now in a few seconds we should see that our Helm release object got created. And because of creating this object, my deployment is also already being deployed into the cluster. Okay, and then if we take a look into what's going on from the perspective of Helm within the cluster, we can see that there are actually 2 releases there, and one is my Flux operator, and the second one is my newly installed demo application. And I have the first revision of this app. So I think I would only show you one more example here, so how we can change something about this release as the last demo for today. So we are still observing what's going on in the cluster. We've got those 3 pods and our application responding. And now I'm applying a different version of this YAML file with my Helm release. And the only change is that I put some custom values here. So I would like to change my green deployment. Currently it's 1 replica, I want to have 2, and currently is version 1.12, and I would like to have a newer version. So again, I'm committing those changes to Git. And then I want to push it to GitHub and observe how the change got applied to the cluster. So that was the previous one when it was first applied. And now after a few seconds, we should see that my change of parameters got actually applied inside the cluster using Helm. So I've got my Helm release configured. And already we can see that new pods are being started with the new version of the application. Okay, and as there is also this Flux Helm operator, we can also take a look here, and we can see that it actually tells us exactly what has changed there. So that there were some parameters changed and the new version got configured. Okay, so that would be it to show you both working together. If we just do Helm ls again, we can see that there is the second revision of my deployment, my Helm release. And I could also do get values for the demo app. And we can see now we have those values configured. Okay, so that would be it to show you those three separate ideas, but they all could work together. And now, just to give you a summary, what this GitOps approach would give us. So basically, to summarize, we want to describe this whole our system declaratively. We want to keep all this description in Git. Then we want to use common processes known from development. So I would like to use pull requests to introduce changes to my cluster. And then only when, for example, some person change, it got automatically applied to the system. And of course, there is this software agent that constantly ensures correctness. So in case anything goes wrong inside my cluster, the agent would apply corrections. Okay, so that would be it, all that I wanted to show you today. Interesting into investigating it a bit more yourself, there are a few links to documentation and to this demo itself. Yeah, and thank you.